Ethanol and ethanoic acid react according to the following equation under condition M and process N to form product Z. The first question, name condition M. The second one, the product Z. The third one, draw the structural formula of product Z. So we are going to do these questions one by one and we show how it is actually done. Look at this equation. Look at the product Z. So to get the product Z, we are going to draw an open structure of this compound. So the first product here, this is ethanol. Okay, the first product is ethanol. That. So we draw the open structure of ethanol, which is like that. Then we are reacting with ethanoic acid. So we are going to change the orientation of this structure so that the two are facing each other. Like this. We start with this H. Then we have O. Then we have C. Double bond O. Then we have C3. So this second product is ethanoic acid. So this is ethanol, just like this. And this is ethanoic acid. So we have made ethanoic acid to face ethanol so that you can see how the reaction will take place. So OH of ethanol will combine with H of ethanoic acid. When OH and H combine, they give us water, which is the same as this product here. Okay? Now we need to look at product Z. So how is the product Z going to be formed? We are going to draw. We are going to write the whole of this the way it is, but omitting OH and H. That is like this. So we have drawn from here this way. Now we skip OH and H because it has already been removed as water. So we continue from O. So these are the products which have been formed. So the product Z is this. So you are asked to draw the structure of product Z. It is this way. You can start from this end coming this way, or you can start from this other end going that way. So what is the name of product Z? So the name of product Z will be from the name of the alcohol and the alkanoic acid. The alcohol lost the hydroxyl group, then it remained the ethyl group. So the first part of the name will be ethyl, because when OH was lost, then you have C3C2 dash, which is an ethyl group. When ethanoic acid lost hydrogen, the remaining part, which is this, is an ethanoic part. So the alkyl part will come from the alcohol. That's like ethyl came from ethanol. The alkanoic part comes from the alkanoic acid, which is ethanoic acid. So the name will be ethyl and then ethanoate. So then the product Z is ethyl ethanoate. If we look at this other product here, this is our product now, which is ethyl ethanoate. How have we formed ethyl ethanoate? The ethyl part, which is this side like this, is coming from ethanol. Ethanoate part is coming from ethanoic acid. So ethanol lost hydroxyl group, which is this one. And then after losing the hydroxyl group, what remained is the ethyl part. Then the ethanoic acid lost what? The hydrogen. And what remained is ethanoate. So this part is ethanoate, this other part is ethyl group. Close up. You see record? And this point here is warming. Okay, warming. If you are asked, then the reagent required is few drops of concentrated sulfuric 6 acid. Next question. State any two differences between the above reaction and that of an hydroxide and an acid. We understand the differences between the reaction between an hydroxide and hydrogen and ethanol and ethanoic acid. The first difference is in the reaction between an hydroxide and hydrogen, a salt and water are home. In the reaction between ethanol and ethanoic acid, an ester and water are home. An ester and water are home. Now, the product during the reaction between an hydroxide and an acid, no smell is produced. But in the case of ethanol and ethanoic acid, a sweet smell is produced. So you can talk about a pleasant smell is produced. Here you say no pleasant smell is produced. You can talk about what? A sweet smell produced. Here you talk about what? No sweet smell produced. Are you together? So that is it. So esters are actually, so the sweet smell is because of what? Production of an ester. And that ester is this one, ethyl ethanate. So the compound is pleasant smelling. Pleasant smelling. Butane is often used as the main component in domestic gas fuels. Calculates its heating value. The general formula for alkanes is CnH2n plus 2. Okay? Now butane is an alkane which has got how many carbon atoms? 4. But is the prefix for 4. So it will be C. The formula is C4, whereby N is equals to what? 4. C4. H, 2N. 2 times 4, 8. We add 2, 10. So it will be C4H8. Now, the molar heat change, okay, delta H is equals to negative 28,770 kilojoules per mole. Now, when you are asked to calculate the heating value, you are being asked to calculate the heat released by 1 gram of this particular substance. So we start first of all to find the molar mass. How many carbon atoms are we seeing here? Carbon are 4. You multiply by the molar mass of carbon, which is 12, which is we are going to get 48. So carbon is 48 grams. We move to hydrogen. How many atoms of hydrogen? There are 10. Times relative atomic mass, which is what? 1. What do you get? You get 11. Now the total mass is 48 plus 11, which is going to be 59 grams. So the molar mass of butane is 59 grams. So you come and say, if the molar mass, which is 59 grams, liberates 2877 kilojoules, what about 1 gram? Then you get the heating value. Just as simple as that. So you get what? 1, which is this one, times, because we are moving diagonally, okay? So time is what? 2877. Then we divide by the molar mass of butane, which is 59. Then you get your answer there. So So number of carbon atoms are 4. We multiply by 12, we get 48. Number of hydrogen atoms are 10. We multiply by 1, which is the relative atomic mass of hydrogen, we get 10. So we add 48 and 10, we get 58. So we ask ourselves, if the molar mass, which is 58, is giving us 2877 kilojoules of heat energy, what about 1 gram? So it will be 1 times 2877 divided by 58. We have got this value, 49.60 kilojoules per gram. Meaning, when you heat butane, 1 gram of butane produces 49.60 kilojoules per mole. This negative sign indicates that the reaction is exothermic. Heat energy is released to the surrounding. We have an overview of what is happening here. Here, we are having an alkyne, a compound which is having how many carbon atoms? 2, with a triple covalent bond. So this compound is known as propene. This compound is known as propyne. It's an alkyne, therefore the name must end with Y. Then we are having step 1. The compound formed is having 2 hydrogens and 1 chlorine. Here we are having 1 hydrogen. So it means here we have added hydrogen. Okay, so what is being added is hydrogen, and then there is also chlorine in that compound. So what is being added is hydrogen chloride. Because here we had 1 hydrogen, but here we are having 2 hydrogen. Here we had only 1 hydrogen, but we are having chlorine. So it means we are adding what? Hydrogen chloride. So this is referred to as hydrohalogenation. So the type of reaction taking place here is a type of addition reaction known as hydrohalogenation. Hydrohalogenation. So you are asked to name the process, you say what? Hydrohalogenation. So the first thing is to understand the scheme. What is hydrohalogenation? Addition of hydrogen halide, a compound of hydrogen and an halogen. So hydrogen and chlorine. Then you have polymer T. So this one is ethyne. The product here is chloroethene. The product here is chloroethene. Because it has 1 chlorine, and because we added hydrogen halide, and this is chloroethene. Okay? The polymer T will be a compound of chloroethene. So polymers, you start with the name poly, that's like from the word polymer, and then you write the name of the monomer. So this one is polychloroethene. Polychloroethene. Like this. Polychloroethene. That's how we have got that. Then we have a process R, whereby how many hydrogens have been added? Here we had 1 hydrogen, but here there are 3. So it means here we have added 2 hydrogens. And here again we have added how many? 2 hydrogens. So it means we have added 2 moles of hydrogen gas, so that we form what? Ethane. This was ethyne, and this one is what? Ethane. So what is the name of the process? Addition reaction known as hydrogenation. So here we are adding hydrogen, so the type of addition reaction is known as hydrogenation. So if you are asked, name the process taking place, what will you say? Hydrogenation. Are we together? Here we are adding bromine, 2 moles of bromine. Okay? So here we'll be having how many bromine atoms? 2 times 2, 4. Are we together? So it will be what? The product here will be bromoethane. But not the normal type of bromoethane, but we must account where these bromines are going. So it will be what? 1, 1, 2, 2, tetra, because we are having how many bromine atoms? 4, which are the same. So it is tetrabromoethane. 1,1,2,2 tetrabromoethane. So this is generally the flow. What is happening? So to get to understand what is happening exactly here, we have seen in the first step, it is hydrohalogenation. So you can start with step 1. What is happening in step 1? So we are starting with ethyne. So we are going to show all the bonds which are present in ethyne. So you have C, triple bond, C, then hydrogen, and then hydrogen. So this structure is the same as this. Then we add hydrogen chloride. So we say plus hydrogen bond chloride, like that. What will happen? Hydrogen will come to one side here, chlorine will go to the other side, like that. What will be the product? The product form will be as follows: carbon, carbon, and then we show what is remaining. So here, hydrogen has come here, chlorine has come here. So what will you have? You will have hydrogen, chlorine, and then in the other side we have hydrogen, which is this hydrogen here, and then another hydrogen which has come here. So you have another hydrogen here. So we follow the normal rule. That is making sure that each carbon atom is surrounded by 4 covalent bonds. So it will be like 1, 2. So how many are remaining? 3, 4. You come to this one. 1, 2, 3, 4. So you put a double covalent bond. So this is ethyne, and this is chloro. Because of this chlorine, chloroethene, like that. So that is how I came up with this chloroethene. Then we come to polymer T. How is polymer T, which is polychloroethene, being formed? You start from ethene, our product here, which is ethene. So we draw ethene like this: carbon, double bond, carbon, and then hydrogen. Then we draw chlorine. Then here hydrogen, and then here hydrogen. So this structure and this structure are the same. These two structures are the same. Only that I've taken this hydrogen up here and this one up here, so that it can be easy for me to do what? To show how it is being bonded. So you put this one into bracket like this, and then you write N. This N refers to the number of what? Monomers. In other words, the number of chloroethene which are present in the polymer. So if there are 10, you write 10. If there are 20, you write 20. But because we don't know there are how many, we just say N. Where N starts from 2. You cannot form a polymer of one monomer. Are we together? So there should be how many? 2 and above? And above. So what do? You show now the having been bonded. So you have C, and then C, a straight line, another straight line, then hydrogen, and then hydrogen, and then chlorine, and then here hydrogen. So because these were N, what do? I hope you have seen that you have actually repeated what was there. This one is this one, this one is this one, this one is this one, and this one is this one. So they were N. How do we show that they were N? You put a bracket like this, and another bracket on this side like this, and then you write N in front there. Make sure that your bracket, the line is cutting through the bracket. Or alternatively, you can draw the 2 molecules of this, and then you show how the 2 of them have been bonded together. That is, or you can do this. You can have C, double bond C, then hydrogen, then hydrogen, then chlorine, then hydrogen. Plus another one like this. Let us show 2 monomers. Let us make our N to be 2. So you have C, double bond C, then hydrogen, then hydrogen, then chlorine, and then hydrogen. Like that. Now, how many carbon atoms are in the longest continuous chain? 1, 2, 3. In other words, these 2 molecules are going to join to form a single molecule. A single molecule which is a long chain. So what will we do? We'll do like this. 1, 2, 3, 4. Put a straight line there, put a straight line here, like that. Then we show this hydrogen, 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 hydrogen. So you show that here they have hydrogen, here hydrogen, here hydrogen, here hydrogen, and then on the lower side, what do we have? Fluorine, hydrogen, fluorine, hydrogen. We do the same thing. We show here that here we have fluorine followed by hydrogen, fluorine followed by hydrogen. So that is it. I hope you are keen enough to realize that I have not put a bracket. In most textbooks, a bracket is put, but that bracket is not correct.